I became introduced to the Hollow Earth when we were doing the research for the Arc of Millions of Years series, which was 2,000 pages, 4 volumes, all nonfiction on 44 ancient cultures and their view of the Earth and mankind's relationship to it. And what became evident after, I don't know, 6 years of research, and I know it seems like we were writing every day for 4 years, was that the ancient cultures believed that the earth had a life energy, had a life force in it, and that man had a kind of symbiotic relationship with the earth. And that as long as man, more or less behaved himself, in other words, the more part of the human race didn't engage in wickedness, then the planet would yield blessings and bounty beyond measure. But if the more part of mankind became wicked and warlike, then the planet had a tendency to rise up and spank mankind back and scatter them down into a few tribes. And that happened in a
This is
variety
happening
of ways.
now. Anyway, go ahead.
Well, I mean, and I'll get to that at the
Okay,
end of the
go ahead,
presentation,
please.
but what became evident was that they really believed it. Now, they had only empirical evidence, just, viewing the stars and what their shaman were telling them and what the earth was telling them and how far they managed to venture into one cave or another, or one mountain or another. But, and I really didn't pay much attention to it until about 2006, when we started taking pictures of the earth from deep space. And one of the things that came back was a picture of auroras. These are like northern lights or southern lights over both poles at the same time. Now that took everybody by surprise, because we kind of thought for a long time that the lights were caused by the solar wind. Whether it's winter or whether it's summer related to the northern hemisphere, the wind would strike that pole of the planet and it would light up when the ions struck the upper atmosphere. So it was really strange to see active auroras over both poles at the same time, because Earth doesn't stand straight up and down on its axis. It's tilted at 23 degrees. So they immediately began launching, in an expedited manner, other space programs to try to really discover the source of the aurora. They launched the Themis probes. They took various magnetometry measurements on the ocean. They put probes on the bottom of the sea. And they also began to take spectrographic measurements of the frequencies coming out of the center of the Earth. This was difficult to do. It took special equipment. And what they were getting was not consistent with a planet full of molten lava. What they were getting was a picture of a planet completely different than that. Then Dr. Y. Sessions published his paper from Washington University. He engaged his grad students, and they got their hands on 600,000 seismograms. These are printouts that are done by various seismographic stations around the planet. They're all printed, so they weren't really entered into computer programs yet. And what they decided to do was create a kind of CAT scan of the Earth, kind of a picture of the Earth based on these heavy earthquake vibrations as they pass through the planet. And of course, they already knew what had been published already. We believed in shear waves and pressure waves or parallel waves and shadow zones. And we just drew the line so that it fit our paradigm, the old paradigm of we live on a molten ball floating through space. However, what became evident was that there was a set of frequencies coming out of the center of the Earth, very strong and very narrow band, like we would normally get if we were, looking at an unknown element with a mass spec. And that was very strange, because we expected it kind of be a soup of some kind. And it wasn't. It was two very defined peaks. What was strange about it is that the one peak was iron, but it was an iron state that only exists in crystalline form. And the only way it could exist at that frequency in crystalline form is if it was at about 6,000 degrees C, which happens to be the temperature of the surface of the sun. But there was another peak, and they determined that that peak was xenon. And this solved a big mystery for us, Because in chemistry, there's a principle called the partial pressure, law of partial pressures. And what this basically means is if you have a liquid that's in, let's say, a Pepsi bottle, the headspace of that bottle, you can take a sample of that headspace, and the molecules that are suspended in gaseous form will be proportional to the molecules that are in liquid form. It's called the law of partial pressures. However, when they take that sample of Earth's atmosphere, we see the xenon in the sea, but we don't see the xenon in the air. It's gone. About 95% of it was missing. And they discovered it locked into this crystalline matrix in the center of the Earth. And now this measurement was then validated by Carnegie Science. Carnegie Science did a much more elaborate experiment. They tried to duplicate the conditions, and they created what's called the diamond anvil press. This is a big industrial diamond about this big, and they cleave it in half, and then they put a crucible in between the two halves, and then they take a hydraulic ram and they crush this crucible with iron infused with xenon, and then they shoot a laser through the diamonds to heat that iron up to 6,000 degrees C, and they got exactly the same set of frequencies. So now we know what the core of the Earth is made of, and we suspect that it is rotating much faster on the same axis as the planet than the crust is. And that's why we have the magnetosphere that we do. That's why it's undulating all the time, because of the Coriolis effect. Everything started falling into place. So I said, well, let's put together a presentation. Let's take it around the country, and let's see if we can raise enough awareness to it to launch an expedition above the Arctic Circle and see if we can find an opening in the crust between the Arctic Ocean and this inner ocean that Dr. Y. Sessions discovered with his CAT scan of the Earth. Of course, that is a multi-million-dollar venture, and it's been a while since we've been trying to raise the money to do that. So we're kind of stuck on that.
So do you suspect, like, there are many people who have books written about a civilization inside the Earth, and maybe people with greenish skin because of the high copper content? I mean, there's a whole genre of inner Earth books. What do you think about life inside the Earth?
Well, I can tell you that if there is space between this core and the inside of the crust, which we believe is somewhere around 900 miles thick, which leaves roughly 1,000 miles between the surface of the core and this inner surface of the Earth. That's 1,000-mile deep atmosphere, full of energy, full of moisture, full of a white light that comes from an iron core, not a fusion star, but like an iron light would be for a grow light. If there is space there, I guarantee you there will be life there. Now, I don't know if it'll be microbial or more complex, but a strange thing happened in 2008. The summer of 2008 was the year that the NOAA decided their regular sampling of rays in Malaysia, like stingrays and manta rays. It turns out rays are very sensitive to pollution, just like, tree frogs in the rainforest. So they take samples every 5 years to look for mutations. Normally they find maybe 20 or 25 new species of rays when they take these samples, because we really don't know everything about our ocean, and we do snag new species. But in 2008, they snagged 1,500 new species of rays. Now, that doesn't come from mutation. That comes from another population altogether. Now, what happened in 2008? Well, as it turns out, the winter of 2007 was a very warm winter in the Arctic, and there was a wind that blew because the jet stream had changed direction. It wasn't the normal polar vortex that we see. It was more lateral across the ice. It created a lot of stress, and a huge state-sized piece of ice calved off of the ice flow. This opened the Northwest Passage for the first time in, I don't know, maybe 500 years. It made a pathway for life to get through that vent in the core up into the Gulf Stream and make its way to Malaysia. Some of this life had been extinct for 1,000,000 years, but it was alive in mature form. So this led us to a location somewhere in a 10,000 square mile. It's about 100 mile by 100 mile window up in the Arctic Ocean. And that's where we're going to go survey.
So there's an outer ocean, the Arctic Ocean. We'll just talk about the North Pole. And some people say it flows in to that core. I don't know. Well, and let's
Well,
also.
at least it connects. At least it connects. Now, remember, the crust is about 900 miles thick. So it's maybe a column of water. But you remember the Arctic Ocean up there is 4 kilometers deep, 4,000 meters deep.
Right. So, okay, let's go over what it actually looks like, the Earth. So you have the surface and the crust, I guess they call it. And the people have said that's about 800 to 900 miles thick. And that's where the continental shelves kind of drift back and forth on, right?
Yeah, well, they're on the very surface of it, and they probably go down maybe 150 miles. And then there's a molten layer in the crust that flows around, and there are openings in that as well. And then there's an inner crust that's cool and obviously has an ocean on the inside of it and mountain ranges and all of that, except there's no horizon there.
And where's the iron? Where's that iron that you tested for?
The iron is another 1,000 miles into the center of the Earth. So we believe the core is somewhere between 1,100 and maybe 1,300 miles in diameter.
The core. And then, well, it's just some of the literature said it's actually a land of the smoky sun from people who've gone out. Some people say the Aurora Borealis is a inner Earth civilization trying to clean our atmosphere. I mean, that's not science for you. That's just hearsay. Would you, or you consider?
Yeah, that's, I mean, obviously there are lots and lots of what we call direct observations. These would be, books like Edidorfa, or books like The Smoky God, or, various personal testimonies, channelers and such. I can't discount it because I'm a pure scientist. I don't just throw out data because it doesn't agree with me. But what I do look for is validation, reliability, and repeatability. And that is missing from all of that data.
What
so
about
I can't throw it out, but I have no duplication.
No. What about Admiral Byrd? Supposedly he's had records of flying towards the South Pole and over that. Have you looked at that?
Oh, absolutely. Yeah, we researched all the factual evidence that we could get. And the story of Admiral Byrd's venture up to Spitsbergen, where he put his plane back together on the beach, I mean, just barely made it before that ship had to get out of there. It was going to be destroyed, the Chantilly. And, there were some differences in his records. One of the differences was that he claimed that he flew straight toward the North Pole at about 2,500 foot altitude, which is insanity in a whiteout conditions. That's why he's an aviation hero and not a statistic, I suppose. And he navigated with a sextant from the pilot's seat. Now, people are really good with a sextant, but to fly and tell your location with a sextant is very difficult to do. And of course he could do it, but he claimed that he flew over the North Pole and that he flew over lush green areas where none should have been, and then returned to Spitsbergen. Well, the issue is that he arrived way earlier than what he should have at that airspeed. He claimed that he had a tailwind going in both directions. Now, a few years later, that route was flown again by another adventurer, and he took longer to get up there, and he saw no such lush green areas. So he says that maybe, Admiral Byrd got off course and then managed to make his way back, and he just actually flew over, Finland instead of over the Arctic area. There's controversy. There always is in science. That's why we look for validation, reliability, and repeatability in the data. And then some years later, there was a diary that emerged. It was late in the 20th century. Al Bielek is my contact to that diary. I read it. I did philology on it, which is the study of the structure of language. And I determined that it was a fake, that it was actually fabricated by a forger. Now, a lot of people believe in it because they want to, but I have no evidence that Admiral Byrd actually was captured by some tractor beam, taken into the inner earth, and introduced to some giant race of advanced beings.
Well, Al Bielek can be a little suspicious. I mean, I like some of what he says, but he was also hard to pin down at times. But now, what about Linda Moulton Howe's investigation with her whistleblowers into the Antarctic? I mean, these are government people. They say, for one thing, you can't fly directly over the South Pole. That's a no-fly zone for anybody. And
yeah, it is a no-fly zone. And one of our members of our team is Brad Olson. He's our Antarctic expert. He actually went down there a year ago and tried to investigate all of these areas. And he talked to several individuals at military bases and people that were actually on the tail end of the research year for that year. And he could not validate any of that. And he's pretty convinced, he'll tell you himself, that he believes that whoever was talking to Linda Moulton Howe was just spinning a yarn.
Well, he couldn't validate it because I'm just kind of taking the other side, because these are whistleblowers, top secret. No one that someone just coming off a boat would want to relay top secret information if they don't have any government credentials. This is what I'm saying. So
true. Yeah, there is something about the Antarctic that, and we've tried several times to take teams down there, but you have to be affiliated. Affiliated means you have to be aligned with a government grant through a university to even get there. Now, that being said, we're trying to put together the money so he and I and one other person can go down there and actually access that area. It's expensive. It's about $16,000 per person to go on this. So we're in the process of raising that money.
Well, if it's accessible, I like Brad. He's a good researcher, but I do doubt top government people were talking to him about the ancient civilization a mile under the ice there. And he didn't even get to those areas that these whistleblowers for Linda are saying have these ancient structures. So there's a lot of mystery to the Antarctic, wouldn't you say?
True. It's true. And I have great respect, for Linda over the years. I mean, she's built an enormous empire, and you can't fault anyone for doing that. I have no lack of respect for her and her research at all.
Well, her research is, I think, pretty solid, and she's an investigator. But either way, if you get to that Northwest Passage or even to the Antarctic, what do you think you'll find, and how will that help the rest of civilization?
Well, that's a really good question. The ship is a nuclear-powered icebreaker. It's Arctica class. It'll take 125 people. So what we have done is we've built a hard science team from 6 different universities, Stanford and Washington University and Cambridge, and a couple of other universities. The names escape me right at the moment. But Johns Hopkins is another one. And their grad student teams are going to go with us. And they're going to be measuring sea chemistry, magnetometry, air chemistry. They're going to be taking micrographs and pictures of sea life at various depths. Some technology we had to invent. One is what I call the sea dart, because it's very deep ocean. The deepest submersible that we can find that's a remote only goes down to 1,000 kilometers, and that's not quite deep enough. We need to go to 4,000 kilometers. To modify that submersible is $5 million, and that we may not have the budget for that. So we invented what's called the sea dart, and this is a dart that we drop off the ship. It goes down through the water, sinks a probe, a coring probe, into the bottom, seals the end of it off, inflates a bag, and then floats back to the surface. We're going to build 4 of these, and we're going to launch as many times as we can, but a round trip is about 3 to 3.5 hours. So what we will be gathering is the first ever samples from the bottom of the Arctic Ocean in this area. And we think that we will find fossilized life or diatoms or even microbial life that is from the interior of the planet. If we do manage to find the opening, we don't know how big it's going to be, it will change everything. It will change the way we view the Earth. And I don't know, but there's a stack of Nobel Prizes to be won there, and it's a great discovery.
Well, it's a fantastic discovery. I totally believe that's possible. Actually, you talked about how, when I asked you at the Contact in the Desert, how the hollowing actually would take place, because any liquid that is spun, like in a pail, it creates a kind of hollowing in the center. You want to just go over that?
We've talked about centripetal forces, which is maybe why planets form as hollow spheres. But I think it goes more toward Newton's law of spheres. He has two basic laws, mathematical laws. One is that on the inside of a thin shell, gravity becomes zero, because the closer you are to one side as the other, it cancels out the gravity from the other side, so you pretty much become weightless. His thick shell physics, which is what would apply to planets, is just an extrapolation of thin shell physics. So it's all theoretical. What we want to do is have empirical backup to that. And as you said, we've only drilled a hole a little more than 8 miles deep. And we're not seeing a drop in gravity in 8 miles. But we have thought experiments that we have run. For instance, if we were in an elevator shaft, in Palm Springs, California, and the shaft went all the way to the center of the earth, and we decided to step onto a bathroom scale at the surface and then send the elevator toward the center of the earth, what would our weight be on the scale? Well, by the time we get all the way to the center of the earth, our weight is zero, because all the mass of the earth is above us. We're no longer accelerating toward the center of the earth because we're at the center of the earth. We're now accelerating toward the crust. And that is why planets form as hollow spheres, some with cores and some without cores.
Well, wouldn't the gravity from the inside of the Earth be from the rotation that would then create?
Not necessarily, because the centripetal force is so slight at that point. It barely has an effect at the equator of the Earth, at the surface of the Earth, which is 7,100 miles in diameter. It barely has an effect. It's rotating faster than the poles, of course, but we only see a very slight bulge, and certainly that's not going to be that way 900 miles closer to the inside of the planet. More probably is the mass of the crust is enormous, and the crust itself will have a gravitational field. It will have an attraction to it from the inside, and that's why we see the ocean on the inside of the crust. I say see, I mean, we can detect it with these CAT scans, and we are seeing the waves crash on the shore on the inside of the planet. And this is an ocean that's larger than the Arctic Ocean, and it sits underneath the Atlantic.
The entire Atlantic has an ocean underneath it, you're saying?
Yes.
How many miles down would you estimate that to be?
I would say 900 miles.
Right. And what about that iron you talked about? Doesn't that have a huge weight to it, or huge gravitational center?
Yes, it does. But you remember, that's 1,200 miles or 1,000 miles away.
Okay.
So gravity decreases with the square of the distance. Now, the interesting thing is when we look at the orbit of Earth around the sun, and we look at what we believe is the density of Earth, which is somewhere around 1 to 1.5 grams per cubic centimeter, the diameter of the planet and the amount of time it takes to go around the sun, these are our calculations, they're a little off. They're off by about 1,200 kilometers. So we're trying to resolve that. And the only way to really resolve it is to realize that the core is much heavier than the crust.
Right.
And once we put that into the equation, we begin to see this gap appear.
That gap is what science thinks it knows and what it really knows. Would you say that?
No, I mean, it's the gap between the core and the crust around it. That's the 1,200 kilometer difference. That's why when we actually look at the amount of time it takes the Earth to go around the sun and the distance from the sun and the mass of the sun, we calculate what should be the distance from the sun to the Earth, and we're off a little bit because of that gap between the core and the crust. Now, if the Earth was smaller and more dense, it'd make perfect sense. but it doesn't, because the Earth is larger and less dense.
Mm.
So it just doesn't make sense to us until we look at this core that is somewhere around 15 grams per cubic centimeter.
What do you think about the expanding Earth theory? Is why continents look like they're being pulled apart. Is there anything to that?
Sure. We think planets are formed one of two ways. We don't really know because we haven't been observing the universe long enough to really see it happen, but we kind of get snapshots of it when we look around the universe with the Hubble telescope. They either form through what are called accretion disks, which are giant spinning disks of gas and particles. And over billions of years, what happens is the center of it forms a sun, and then in Fibonacci rings around it, it forms planets. We think we can see examples of this out there in space. If that's the case, then planets fall into one of three categories. As they get smaller and smaller and smaller, they begin to spin faster and faster and faster. It's the law of conservation of momentum. Well, one of three things happens. They either spin so fast that they explode, which we see in maybe our asteroid belt. They get lopsided, a heavy part of it spins to one side, and they spit off a piece of themselves as a moon. And we have an example of that in our solar system, Venus and Mercury.
Right.
And then there's kind of the Goldilocks, which is where the crust expands and cools and expands and cools and expands and cools. And that's exactly what planet Earth is doing right now. The crust is still expanding. It's still filling in with molten material. In short, the diameter of planet Earth is changing slightly, but it could have slowed way down and become very asymptotic over the 4.5 billion years that the planet has existed. The other way that planets form is electrically. We have more examples of these big gas clouds experiencing a gigantic electric arcs that go shooting through it in kind of a random pattern. And where this lightning or where this electricity balls up, it forms planets, it forms stars. We think, and we're getting more and more evidence of this every day, more and more new physicists and astrophysicists are creating theories. We think we live in an electric universe. And in that case, it helps us understand why we don't have enough mass in the universe to explain how galaxies rotate around one another, because the distances are just too far apart. We create dark matter and dark energy to make up the difference, but we don't really know that for sure. What we think now is that the universe is kind of electromagnetic in the way that it ties galaxies and solar systems together. It seems to make a lot more sense.
So if we knew that, if that became the science of the day, how would that change our standard science, and what advance in technology would happen if we based it on that theory of electromagnetism?
Well, it does change our view of the universe and how long it takes for things to form. It also might change the speed limit of the universe. It might not be the speed of light after all. There may be interdimensional ways of traveling in physical form around the universe. We're not there yet, but we're experimenting with it.
So if that change, let's say your theories are right, and then how does that access or give us access to free energy? Because obviously the planet's free energy, the sun, everything, there's so much. What's your whole idea about that?
Well, obviously the Earth has a lot of energy. I mean, room temperature is 273 degrees Kelvin. Tesla said, hey, this is a lot of energy. We should be able to tap into it. The problem with free energy is developing the potential. Yeah, the electricity is there, the energy is there, but we don't have another side of the plate to step on in order to get the potential to make flow.
Not yet.
So
not yet.
But the next rung in the ladder for us is fusion technology, fusion rocketry, fusion energy, and the Mac Daddy gold rush of the millennia is on the moon. It's helium-3.
Helium-3 is where on the moon rocks or in the atmosphere? Where?
No, it's in the South Pole in what's called Schrodinger's Basin, which is a basin that's basically the south pole of the moon. There are huge craters. One is called the Shackelford crater. It's about a little bit bigger than Mount Everest upside down in the planet. And because it's the South Pole, it's shaded. And so we believe that it's full of frozen helium-3, solid helium-3. So we could go up there and core that and collect it and use it as fusion fuel.
Is that what fusion fuel needs, helium-3? Is that the...
Well, we see, the thing is that we can do fusion now, but we do it with hydrogen, and it's very radioactive because it spews neutrons everywhere. The beauty about helium-3 is when it fuses together to make helium-4, it spits off protons. This is a big difference for two reasons. One, we can use the protons for electricity because we can charge them. The second thing is there's no radiation. There's no radiation, which means we could replace the cores of all of our nuclear power plants and run them on helium-3 for 1,000 years with no radioactive waste. And all the fuel is sitting 2 days away on the moon.
Wow. But someone asked a question here. What if gravity and magnetism were dipolar forces concerning the orbits of galaxies? Also, Nassim Haramein says there's only two forces, no weak or strong. There's only electromagnetism, which pulls things out, and gravity, which pulls things in. They're really poles of the same force. Yeah.
Yeah. I mean, the whole field of astrophysics took a huge leap forward a couple of years ago with Garrett Lisi. Garrett Lisi discovered inadvertently the origin of the golden mean. And this was an enormous discovery because we know the principle's true. We know that energy that falls upon this, what we call a Fibonacci process of increase, this instantaneous rate of change of 1.618 to 1, or phi, we know that it's constructively interfering. And we believe very strongly that this is how matter is formed.
And life itself, not just matter, living matter, would you say?
Sure. Well, I mean, all matter is molecular. So yes.
But Fibonacci related, I mean, you know, or phi ratios.
Right.
So,
we didn't really know what the origin was, though. We know the principle. We didn't know where it came from. And Garrett Lisi did a marvelous thought experiment, which we then duplicated in physical labs, physical chemistry labs. It's called particle stacking, where we took the, let's see if I can grab it here. We took the tetrahedron, which is the smallest shape that goes from 2 dimensions to 3 dimensions, okay, like a pyramid, but with 3 sides.
right.
We stack these as close as we can get them. We draw a sphere around these 4 points, and then we remove the sphere and put a point in the center. It's called point space. Then we draw vertices between those points, which is an 8-dimensional version of matter, of energy. But then we need to get that in the 4th dimension, which is 3rd dimension plus time. You'd think, oh, just cut the sucker in half, right? But that's not the way it works. In spherical mathematics, we have to take the square root. Now, normally when we take the square root, like the square root of 4, you get 2 and 2, right? 2 equal halves. Not so when you divide the point space sphere. You get the ratio 1.618 to 1. And it's validatable and verifiable and repeatable. It has totally changed the field of theoretical physics. We now believe, well, we now theorize that the 5th force of the universe, which may actually be the primary force of the universe, is consciousness. And as you can tell, that's really changing our field a lot. Guys like Nassim and myself and Garrett and others, we're changing the way we think about physics.
Yeah, Dan Winter's someone else who you might want to look into if you don't know him. But so if consciousness is the 5th force, what is the relationship between consciousness and the phi ratio? Because you've discovered a ratio there.
Well, that's getting a little bit out of my realm, but
okay, we don't have to go there. I got more questions.
Okay, yeah,
that's okay. No, I mean, I think you're explaining it. I mean, people have to have a little bit of a background, but I think it's really brilliant. So what do you say then is the future for the planet? If you were in charge of technology, if you, I mean, you get the helium, talk about the future for humanity?
I think that Mother Nature kind of gave us a boost by giving us, hydrocarbons to burn. And we are, happily shoveling our planet into our gas tanks and burning it. But it's a temporary fix. It's just meant to get us kind of into the Industrial Revolution and know how to build stuff and how to fly. Now we're ready to go to the next level. Now this may, step in the sandbox of the energy barons, but if I were in charge, this is what I would do. I would move us toward fusion as a source of energy, because interesting things are going to happen when we do. First of all, it cuts the amount of time it takes to get from Earth to Mars from 7 months to about 70 days.
Wow.
And it gives us artificial gravity, which is a huge difference. We now, once we get to Mars, we can now access the asteroid belt. The asteroid belt has enough minerals, enough pure energy to supply the solar system for many, many millennia. That's the next generation for humankind. It may mean the end of money as a system of exchange, because there'll be so much value in the system that no human, literally no human, would be left behind.
That's what we need. We need a fair economy where energy is accessible to all. But now that you're talking about energy motions, what do you think of ET technology, or what some of the, crash retrieval have revealed about how they're flying?
I've been close to NASA at JPL since I was in high school. In fact, 2 of my high school friends ended up working for Hughes. They launched the GPS satellites. One of my friends even owns a part of the Iridium satellite, so they're still in the business. I know as close as anybody that I can imagine how much space technology we actually have our hands on. I think that there is ET technology out there because obviously we can see it. Obviously, we're chasing it with F-18 Super Hornets, and we can't catch it. And it's been that way for a long time. What we do know for sure is that we're not alone on this planet. We don't know if they came from other worlds or if they were here long before us, and they just don't want to live with us. They're a much smaller population than us, but we know that they're as present as they want to be.
Right.
And that's just all I know about it. All I know is the most advanced space travel that we have, we are still putting humans on top of candles and lighting them.
I know, it's ridiculous. It's very primitive. I mean, the ancient Greeks had steam engines. We haven't evolved too much further than that.
No, we really haven't. We're still using steam. We're still using hydrogen peroxide, or the Germans just tested a paraffin, a candle wax engine. They're small.
Combustible engines, it went out of date with the 1800s, basically. I mean, we're still running on that technology. But when I interviewed Hal Puthoff, I asked him that question. He says, and he didn't give me anything official, but he said, if you can take the space-time away from the moving object, it would propel itself at the speed of light. I mean, that's sort of a rough estimate. What do you think of that?
Well, all the theories that I have read, and I submitted a paper to CERN about a decade ago about this, is that there is something in the universe that we have observed. It's called exotic matter. We think that this is what neutron stars are made out of, old collapsed giant stars, or even black holes, the singularity in black holes. And there's been lots of argument about that, which is healthy. My paper was a theory that singularities in black holes are not a single point, but they are a Heisenberg uncertainty, and that they actually form around the event horizon a spinning ring of exotic matter, which means that in the center area of these supermassive spinning black holes, matter is not annihilated. It passes through a Einstein-Rosen bridge, but we don't know where it goes to or comes from. What we do observe, and when I was at the LIGO, the Laser Interferometer Gravitational Wave Observatory in Hanford, Washington, and also Livingston, Louisiana. I was supposed to work at the one in Italy this summer, but that trip got canceled. What we're observing is that particles are actually popping into our dimension from another dimension. We observe it. This instrument's extremely sensitive. It can measure all the way down to a Planck length. And that's what we're seeing. We're seeing particles pop into our dimension from another dimension. So Stephen Hawking was correct that our universe is leaking into another universe. But what I added to it is that other universes are leaking into ours.
Right.
So there is a way to move interdimensionally that is independent of the speed of light, because the speed of light becomes non-essential in heavy gravitational fields.
Right, that's old Einsteinian physics. That doesn't apply to what now is being discovered. But if there's particles that are moving between dimensions and universes, there could be entities or beings.
It could be, because these particles do carry information. What we've seen in the more modern patents, especially the one that was recently filed by the U.S. Navy, is that this exotic matter is at the core of some of this propulsion technology. The problem is that, a tablespoon of this exotic matter would fall through the Earth to the center of the core instantly, because it's that dense. You can't contain it. I don't see how a ship the size of a large Tic Tac is going to hold exotic matter in the center of it.
Unless it's made of some type of material that can do that. Just one more thing, and then I have another question from the chat. When we get to heavy gravity, doesn't that warp time as well?
Sure.
And so what does that orientate us towards if we're warping time?
Well, what happens is, outside of that heavy gravitational field, time goes normally. But inside that gravitational field, time slows down. It slows down relative to the outside. It runs the same on the inside, but it's just relative to the outside, time changes. And we realize also that at the speed of light, time becomes zero, or mathematically, mass becomes infinity, which effectively means the Big Bang never happened. It's actually human consciousness that slowed the universe down so we can observe it.
Wow, that is great. Or not, maybe not just human consciousness, but this self-awareness that sentient beings are here to play out in this field of creation. Someone says, do you know what kind of information comes through with those particles?
Yeah, we have deciphered a lot of it. Some we can tell if stars are spinning or not, or we can tell what they're made of. We can tell if they're moving toward us or away from us. These are basic bits of information. And we're getting better at it. We're getting more and more particles. We're beginning to decode that information. It isn't like a book, but it is basic information that we can get. So when I say these photons carry information, that's what I mean.
I mean, I love what you're telling us, because what you're basically saying is we are at the brink of a new scientific revolution that will make everything.
We're past the brink.
Okay.
The issue is that, I'm sorry to say, in our science anyway, and I think in geology as well, for sure, anthropology and archaeology, they're stuck. They have a religiosity about them, and they will not accept new ideas because you undo all of their PhDs. Right. So you kind of have to wait for the old generation of high priests to die off before the new thinking can make stuff happen. But and I'm sorry to say, a lot of it is political, because, and my brother was one of them. He's 9 years older than I am. He's now professor emeritus, but that's what he did. He went to DC and got grant money. And so it's very political as well.
No, I forgot who said science progresses one funeral at a time, because
that's pretty true.
And so someone also asked, why aren't we going to Antarctica and Mars? I guess that's a whole other thing. You know.
Well, we have active science projects going in Antarctica. The work year is only about 70 days. You go down in November, and you're out in January. That's the end of the season. The Arctic, it's a little bit longer than that. We can go up, late May, and you can stay until almost the end of August, and then it freezes so fast you almost can't beat it. You have to have an icebreaker to get out of there.
Well, we could talk for hours about this. I think we have someone else coming, but I really appreciate your groundedness, your scientific mind, and the fact that there is an evolution to knowledge, and we need to embrace that.
Sure, absolutely. Absolutely. I'm so on the hard science side that I'm kind of the tether that's keeping the more esoteric people in check, because we can get really crazy with this stuff. And I don't want to lead anybody astray. I want to keep everybody, going toward truth and exploration. And I still want to be on the Ascension panel.
Well, yeah, we're ready for you on the Ascension panel. We'll talk to Neil about that. Hey, just give people your information, reach
Yes.
you. Yeah.
Absolutely. You can get everything I'm doing at brooksagnew.com. All my science projects, my podcast is there, the books I've written, everything is there. We're working on a film to put some of the books into film. So everything's at brooksagnew.com.
Well, maybe I'll go to the inner earth with you. That's
That's a rough ride. It's 100-foot seas. You'll be in the room of doom for 10 days.
maybe
I would rather go and watch it on the live stream than hanging over the rail.
Hey, Brooks, thanks so much for joining us on Portal to Ascension. You are on the Ascension. Just joining us here, you're on the Ascension panel.
My pleasure. Thank you so much for letting me be part of Portal to Ascension.